nomenclature system of aldehyde, ketone and carboxylic acid. The next point is methods of preparation. In this we will consider general methods of preparation of aldehyde and ketones. Here some general methods are: one is by oxidation of alcohol, by dehydrogenation of alcohol, then from hydrocarbon, first is ozonolysis, second is by hydration of alkynes. We have seen these reactions in previous chapter, that is alcohol, or some reactions we studied in 11th standard. Now we will consider some examples of these reactions. First is by oxidation of alcohol. Oxidation of alcohol. So remember one point, that when primary alcohol is oxidized by using PCC, that is pyridinium chlorochromate, then you will get aldehyde as product. So this is one method which you learn in alcohol. So remember this, when primary alcohol is oxidized by using pyridinium chlorochromate, then it gives corresponding aldehyde. Here we have to use pyridinium chlorochromate, because if we use acidified potassium dichromate, then reaction never stop at aldehydic stage, but we get carboxylic acid as a final product, and therefore we have to use this pyridinium chlorochromate. Then secondary alcohol, when oxidized by using chromic acid, CrO3, that is chromic acid, then we get CH3, C11O, CH3 plus H2O. Here you remember that common name system, you should know common name system as well as IUPAC nomenclature system. Here this is ethyl alcohol, which is common name system. This is acetaldehyde, common name system, as well as you should remember IUPAC nomenclature system. So this is ethanol or ethane 1-ol, and this one is ethanol. So remember this common name system as well as IUPAC nomenclature. This is isopropyl alcohol, this is acetone, and IUPAC name is propane 2-ol, and this is propane 2-ol. So remember common name system as well as IUPAC nomenclature system. Then next method which you learn in 11th standard, that is dehydrogenation of alcohol, which gives alkene. If we use tertiary alcohol, and therefore we have to consider primary and secondary alcohol only. You remember this. Here if we use primary alcohol, CH3, CH2OH, if it is heated at 573 Kelvin in copper tube, then we will get CH3, C11OH plus H2 gas. So this is dehydrogenation reaction. So remember primary alcohol gives aldehyde. This is ethyl alcohol which gives ethanol. This is ethanol which gives ethanol. So remember both common name as well as IUPAC name. Then second example is, if secondary alcohol is dehydrogenated by using copper at 573 Kelvin, then we will get ketone. So this is the reaction. So remember, when secondary alcohol undergo dehydrogenation, then it gives ketone, and if we use tertiary alcohol, then it gives alkene. So remember these two reactions which are based on alcohol, that is, first is by oxidation of alcohol and second is by dehydrogenation of alcohol. So remember these reactions, its common name system and nomenclature system. Here, while writing these reactions should be balanced, and second point is these conditions should be mentioned properly. So this is about first method, that is by oxidation of alcohol and by dehydrogenation. The next part is from hydrocarbon. From hydrocarbon. So first reaction is ozonolysis. In 11th standard, you learn this reaction in alkene, alkynes and even aromatic compounds. So ozonolysis. We'll consider this example CH3, CH double bond, CH2 plus ozone in presence of CCl4. Then we will get CH3, CO, CH2, O, O. So this is called as ozonide. This is called as ozonide. This ozonide on hydrolysis followed by reduction, gives CH3, that is aldehyde. One product is aldehyde, another is also formaldehyde, and their side product form is zinc oxide. You remember one thing, if this terminal carbon-carbon double bond is present, then one product is formaldehyde. So this is very important. If you want to prepare ketone, then you take this substituted alkene. If it undergo ozonolysis in presence of CCl4 as a solvent, then we will get this ozonide. This is ozonide. This ozonide on hydrolysis followed by reduction gives CH3 double bond O plus O double bond CH3. So this bond breaks in this way, and you will get CH3COH, CH3CO, CH3. So if you remember this shortcut, then break this bond, write this double bond as it is, put one oxygen, break, then write this part here which is toward the right hand side, then write carbon oxygen double bond and put oxygen. So you remember this. Now here, if terminal carbon-carbon double bond is present, then one of the product is formaldehyde, and if non-terminal double bond is present or alkene is there, then you will get this aldehyde or ketone depending upon which groups are present. But if terminal is there, you will get formaldehyde, and for non-terminal you will not get any formaldehyde molecule. So remember this ozonolysis reaction. By using this reaction we can prepare acetaldehyde, formaldehyde, acetone, or this again acetaldehyde. So this is another method by which we can prepare this aldehyde and ketone. The next method is by hydration of alkynes. Consider this example. HC triple bond CH. This is acetylene plus 40% H2SO4 and 1% HgSO4, that is sulfuric acid and here mercuric sulfate. Then hydrolysis takes place here, as carbon-carbon triple bond contains 2 pi bond and 1 sigma bond. Pi bonds are weaker than sigma bond, so it easily breaks. and you will get HCH double bond COH and H. So addition of water takes place. So here you can write water, addition of water. This compound contains OH group as well as double bond group. So this is named as vinyl alcohol. Vinyl alcohol. This vinyl alcohol is unstable and hence it easily undergo tautomerism. So it forms tautomers. Tautomerism. And you will get H, CH, H, single bond, double bond O and H. So tautomerism is what? When ketone and enol form are at equilibrium, then it is called as tautomerism, and such isomers are tautomers. So vinyl alcohol gives acetaldehyde. It gives acetaldehyde. Like this, if we use substituted alkynes, this is unsubstituted alkyne, this is substituted alkyne. Its name is methylacetylene, or it is prop-1-YN. Okay, En is replaced by Yn. So prop-1-YN. Then when it is treated with 40% H2SO4, 1% HgSO4, then you will get CH3, COH, double bond, CHH. Here this reaction takes place according to Markovnikov's rule. So you remember Markovnikov's rule that in an addition of this unsymmetrical reagent to unsymmetrical alkynes or alkenes, the negative part of adding group or adding reagent goes to carbon having less number of hydrogen. So at second carbon, number of hydrogen is 0 and hence OH goes to this carbon. Now this is unstable compound and this is also vinyl alcohol. Vinyl alcohol, because as you know that if OH group is attached to sp2 carbon, then it is, or any functional group is attached to sp2 carbon, then it is considered as vinyl. So this is vinyl alcohol. When it undergoes such tautomerism, then you will get CH3, CO, CH3. So this is acetone. So we can prepare this aldehyde as well as ketone by using hydrocarbons, that is hydration of alkynes, as well as by ozonolysis. You write these reactions because reactions are not given in your textbook, because we learn this in previous lecture, previous year or previous chapter, and therefore it is not given in your textbook, and hence you write these reactions, write balanced reaction. This is very important. Okay.